Yeah. So here we have to justify that the logarithm of that infinite series divided by pi squared is 0. And what we're going to do is just prove that the inside is 1, so that this is just log of 1, which is 0. So we want to prove that this is 1, and that is equivalent to this. If I take out that 6 as a common factor, then I get a 6 over pi squared in front, and then the infinite series of 1 over n squared. But now it turns out that that's a famous theorem of Euler, that the sum of the reciprocal of the squares is actually equal to pi squared over 6. That's something called the Basel problem, and some very famous theorem of Euler. Then the sum of the reciprocals of the squares times 6 over pi squared is equal to 6 over pi squared times pi squared over 6. So it's 1, and the log of 1 is 0. This problem might make you think about other sums of reciprocals. For example, what about the reciprocals of the cubes, and what is the value of this number? This number, there's a lot of interest in this kind of numbers. This one in particular is called Apery's constant, because Apery proved in 1978 that this is an irrational number, but we do not have a closed formula just like we have for the reciprocal of the squares. We have Euler's theorem. We don't have a nice closed formula like that. We do have some other integral formulas for it and all sorts of other formulas, but not a beautiful theorem like Euler's. But for example, an open problem in mathematics is to prove that this number is transcendental. Clearly this is transcendental because pi is transcendental, but we do not know yet if this is a transcendental number.